Hi children, how are you all? How are you doing all? I hope all you are doing well. So in the previous video we discussed about that concept algebraic equations, right? So now we are going to discuss about that concept. While you are seeing the screen, you have one of that idea, right? We are going to discuss about the concept polynomials and factorization. But children, here before going to explain about that polynomials, we have to discuss about that algebraic expressions. Why? Because already you know that polynomials is one of the type of algebraic expression, right? So that's why here first, before going to discuss about that polynomials and factorization, actually here factorization is that another concept, no? So that's why first, before going to discuss about that polynomials, we have to start with algebraic expressions. So after the completion of algebraic expressions, some terms there, no? So after completion of that, we will discuss about that polynomials. Okay. So children, let us say that the first term from that algebraic expression, that is variable. Without knowing about that variable, we don't know that if, actually here polynomials means each and every term is having that variables, and as well as we are having that constants. Just now I told you that one of the word, that is a term. Okay, so before going to that concept, what about the term? Okay, so term means here that is the combination of a variable and a constant, or a single variable or single constant. What about the variable? Already we discussed in that previous topic, so once again we will recall that. So first thing, variable means a symbol which has a symbol which can take any value of a certain set. So it doesn't have a fixed value, then we will call those as variables. So variables means we can take here alphabets A, B, C and so on. Here we can take that X, Y, Z. Mostly we can say that X, Y, Z, right? Okay, so here these all are called variables. So variables, which one we have to take? We can take that one as alphabets, we will take it as some variables. So these all we will call it as literals. Okay, now come to that constant. Okay, so constant means a symbol which has a fixed value. Here variable means it can take any value of a certain set, that is based on that given equation. The value of that variable, it may different. Okay, but here constant means wherever you will write that symbol, but that has a particular value, it has a fixed value, then we will call those values are constants. Okay, so here we can take that numerical values. Any numericals we can take it as some constants, right? So here after that constant we have the term. What is that? Term. So term means a single variable also we will consider it as a variable. We will consider it as a term, and in the same way a single constant also we can take it as a term. Okay, or else the combination of a variable and a constant. Okay, by using two fundamental operations, what are those means? Multiplication and division. This is called about that term. So after that term we have that degree of a term. Degree of a term also we discussed. So what is that? For example here 5PQR, it is one of the term. Okay, why? Because this is consisting of a constant as well as this is having that variables, and those all also having that fundamental operation multiplication. Okay, so that's why here we will call this one as a term. We will call this one as a one term. Now degree of a term means we have to add the powers of the variables in a term. Okay, degree of a term means we have to add that all the powers of each variable in a term. Okay, so that's why here what are the powers here? 1 plus 1 plus 1. So which is equals to 3, no? So what is the degree of this term here? So the degree of this term is 3. Okay, now take that another example. P square Q R power 3 R cube. Okay, so here what is the degree? So here again this is one of the term, no? So 2 plus 1 3, 3 plus 3 is equals to 6. So here 6 is the degree of the term. Okay, now you have idea, right? Now I told you that a positive powers and negative powers of a term also. So positive power of a term means while you are saying this term here 5PQR. So when you observe the powers of here, powers of the term, all are having that positive powers only, no? Okay, so we will call this one as this is a term and this is having positive powers. For example here 5 by x is there, 5 by x. So x is in the denominator, no? So if you write that one in that numerator, that one becomes as x power minus 1. 5 into x power minus 1. Why? Because here again 5 into x power minus 1 means that is 1 by x. So 5 into 1 by x is equals to 5 by x. Is it clear to you? Okay, so that's why here, now when you observe this term, here x is having that negative power, no? So that's why this term is having that negative power. Okay, so terms are having that positive powers as well as negative powers also. Okay, why I am saying this one, later we will discuss about that. Okay, next one. Next here, expression means a single term or the combination of terms by using that addition or subtraction. So for example here, x is one of the term and here 3 is another term. Okay, so the combination of two terms by using that addition or subtraction, then we will call that one as expression. Okay, so here x plus 3 is one of the expression. Okay, and we can write here 2 plus 4 also one of the expression. Okay, so maybe you have a doubt, madam here 2 into 3, okay, while you are using that multiplication, is it a term or not? That is also a term. Why? Because I told you that about the expression, a single term or the combination of terms. Here I am saying that a single term or the combination of terms by using addition or subtraction I am saying. So here 2 into 3 is there. So 2 into 3 means that is 6. So we can write this one as a into b is equals to ab also, no? A into b is equals to ab. So we can consider that ab is one of the term here. Okay, so that's why here multiplication also we can take as well as the division also we can take. So here while you are writing this one, here 2 into 3 I am writing, no? So that is also one of the expression only. But here a difference between these two expressions. What is the difference? When you observe that this expression, here we can observe that two constants. Okay, two numerical values there in that expression. And here when you observe this one, here one constant value, which means one numerical value, one variable is there. Okay, so that is the difference, no? So we will call this expression as a numerical expression. We will call this one as a numerical expression. And what about this one? If an expression is containing at least one variable, then we will call that one as algebraic expression. Then we will call that one as algebraic expression. Is it clear to you? Okay, so we have the two types of expressions. One is numerical expression, another one is algebraic expression. So numerical expression means here that expression is consisting only constants. Okay, and here algebraic expression means an expression which containing at least one variable. So we can take that x plus y. So x plus y is one of the expression as well as that is consisting of two variables. So at least means minimum it has one variable. Then only we will call that one as algebraic expression. Okay, now we will see about that types of algebraic expressions. Okay, so first one, if an expression containing only one term, an expression which is containing only one term, then we will call that one as a monomial. We will call that one as a monomial. And here I am saying only one term, no, and its powers also must be positive powers. Okay, that term is also having that, should have that positive powers, then only we will call that one as a monomial. Okay, so if that an expression which contains two terms, then that is called binomial. That is called binomial. So here how many terms there? Two terms. So we can say this one as an expression which is containing two monomials. Why? Because here monomial means that expression is containing only one term with positive powers. Okay, that's why here binomial we can say this one as an expression which contains two monomials. Which contains two monomials, which means here binomial also having that positive powers only. Okay, so here also we can say that powers are positive. Next, if an expression containing three terms, then we will call that one as a trinomial. Okay, we will call that one as a trinomial. Okay, so trinomial means here 3 terms, as well as we can say another definition for trinomial, an expression which contains three monomials. Why? Because here a trinomial is also having powers are positive. That's why powers are positive means monomials only, no? So that's why here an expression which contains three monomials, then we will call that one as a trinomial. Okay, so here also powers are positive. Next come to that, another type is a polynomial. Okay, this is our lesson. So once see that polynomial means an expression which is having one or more than one term. One or more than one terms, then we will call them as polynomials. So we can say that monomial is a polynomial, trinomial is a polynomial, binomial is also a polynomial. Did you understand that? An expression which contains one or more than one term, then we will call them as polynomials. But what is the difference, madam? Here this is having only one term, this is having two terms, and this is having three terms, and this is having one or more than one. One or more than one. So here we can't say that exactly how many terms. So poly means many terms are there. Okay, so that is a polynomial. And here I told you that monomial is a polynomial, binomial is a polynomial, trinomial is a polynomial. So here why? Because here all are having positive terms, no? I mean positive powers, no? So that's why here we can say that polynomials also having that powers are positive. Powers are positive. Later I will tell the definition of a polynomial, just to see that here. So next thing is a multinomial. Okay, so here multinomial means this is also just like that polynomial only, but here the powers may be positive or negative powers also there. Okay, in that multinomial we can say that negative powers also. I will give you that examples while I am explaining that polynomials. I will give that. Okay, so again you can see these all types in that polynomials also. Okay, so that's why. So every polynomial we can say that one is a multinomial. Okay, so our topic is a polynomial. So today we are going to discuss about the concept polynomials and factorization. So this is the introduction part about that polynomials. Okay, so what about that polynomial means? An algebraic expression in which variables in each term is having powers are non-negative integers. Okay, so what about this one means? An algebraic expression in which each variable having that powers, each variable power or powers are negative or non-negative integers. Or non-negative integers means those are positive integers only, no? So here they are saying that the power of that variable in each term, should be non-negative integer, which means should be positive integer. Okay, so here polynomial we will represent that one as a p of x. So here p of x means that polynomial is in terms of x. Polynomial in terms of x. That is the meaning of that p of x. Okay, so after that I hope you understand about that polynomials definition. Okay, already I told you about that monomials, trinomials, binomials and so on, right? So here polynomials means that is consisting positive powers. So for example here ax square plus bx plus c. So this is one of the expression, no? So this expression is having that the power of the term is here 2 and here its power is 1. Okay, and constant power is 0, we know that. Okay, so here powers of that each variable in each term is non-negative integer. So these two are positive integers only, no? So we will call this one as a polynomial. Is it clear to you? Okay, so here A is called the coefficient of x square, B is called the coefficient of x, and C is constant. Okay, now see here. Okay, here we can say that like terms and unlike terms of a polynomial is also, right? Like terms and unlike terms. So in a polynomial we are saying that is having one term or more than one term we are saying. So in the terms, like terms and unlike terms. So like term means what here? Like terms means minus 5ab, 4ab, 1 by 3ab. Okay, so when you observe that these three polynomials, these three terms, when you observe that these three terms here, this is having that AB, AB, AB. So these three also having that the common thing, that is AB only, no? So here it's a constant value, whatever it may be, there is a change in its constant value, but here there is no change in its variables. Okay, so these three terms also having that the same variables, no? So that's why we will call them as like terms. Okay, next unlike terms means minus 5ab, 1 by 2a, 1 by 3b, and so on. So when you observe this one, here this is minus 5ab, 1 by 2a, 1 by 3b. Okay, so this is having that the term as containing ab variable, and here this is containing a and this is b. Okay, so when you observe this one, here AB term is there, here only A is there, here only B is there. So there is a change in it or not? Whatever it may be, no need to say about that constant values, just you have to observe that only variables. If the terms are having that same variables as it is how they are in all. Okay, so here AB, AB, AB. So in these all terms also we are having that AB as a common term. Okay, so that's why we will call this one as a like term. But here different is there, no, different variables. Here A B there, here only A there, B is not there, here A is not there. So we will call this type of terms are unlike terms. What we will call them? Unlike terms. So here we can say that coefficients. So coefficients means, so just I written here minus 5ab, no? So here coefficients, here we can say that two types of coefficients, numerical coefficients and literal coefficients. So literals means simply we know that alphabets only, no? So in this term, literal coefficients are AB. AB are literal coefficients and minus 5 is a numerical coefficient. So my question is, in the term minus 5AB, here literal coefficients are dash. Okay, so here literal coefficients, what are those? Yes, AB are that literal coefficients. What is that numerical coefficient? In the term minus 5AB, minus 5 is that a numerical coefficient. Is it clear to you? And in the same way here we can say that here a literal coefficient, I am saying the word literal means you have to go for that AB, only variables. If I will ask you that a numerical coefficient means, again I am mentioning here, numerical coefficient. So you have to go for that only constant values. Okay, so my question now, what are the coefficients of A in the term minus 5AB? What are the coefficients of A in the term minus 5AB? So coefficients only I am asking. I am not saying that literal coefficients or numerical coefficients. Just I am asking that coefficients. So in the term minus 5AB, what are the coefficients of A I am asking. So which term I am writing here? Except that term, the leftover remaining ones you have to write here. Except that variable or that is a constant, whatever it may be, they will ask, depends on the question. So A I am asking, so leave that A. Except that A, remaining two, what are those? Minus 5 and B. So minus 5B is that coefficient of A. Minus 5B is that coefficient of A. For example here, minus 5AB, what is the coefficient of B? What is the coefficient of B? Here I am asking about B. So the leftover one minus 5A is the coefficient. Okay. And in the same way, what is the coefficient of minus 5 in the term minus 5AB? Okay, so here coefficient is minus 5 coefficient I am asking. So the leftover one AB. So AB is that coefficient of minus 5. Okay, so these all things we have to discuss about that before the polynomials. But here Just to give that clarification, I am giving you here this one for extra knowledge only. Okay, so after that polynomials, you have one of the idea, right? So in that next video we are going to discuss about that types of polynomials. Here again we can say on depends on that two cases. First one based on that number of terms, and based on that degree of that polynomial. Okay, so depends on the degree we can say, as well as depends on that number of terms also we can say that types of polynomials. Okay, so we will discuss that one in that next video. Okay.